So in this question, I believe it's question 4, it's multiple choice, and it says choose the correct equation for an arithmetic sequence in which the fourth spot is equal to 19 and the second spot is 11. So I could think about this sequence. Here's the first spot. The second spot is the number 11. I don't know the third, but I do know the fourth is 19. So if I think about it like that, in order to move from here to here, because it's arithmetic, I know that I'm going to be adding the same thing twice. So the question is, what do I add to the number 11 twice in order to get up to 19? So, like if I was to add 2 each time, 11, 12, 13, 13, 14, 15, that wouldn't be enough. I'd only get to 15. If I add 3 each time, 11, 12, 13, 14, 15, 16, 17, that's interesting, but that's not enough either. So let me try and add 4. So 11, 12, 13, 14, 15, 15, 16, 17, 18, 19. Okay, so it is that I'm adding 4 each time, and I'm going to hit the number, I think 15 here. So 11 plus 4 is 15. 15 plus 4 is 19. And if I want to go back and calculate the first term, 11, let's see, 11 minus 4, that would be 7, right? 7, 8, 9, 10, 11. Yeah, this would be 7. So I can see the first term. And actually, if I wanted the 0th term, because I kind of need that to write the explicit rule, 7 minus 4 would give me a 3. So I can see here that my 0th term is the number 3, and I can see as I move forward each time I'm adding a value of 4. Right? And I'm saying this with confidence because I'm told it's arithmetic, so this is how an arithmetic sequence would behave, even though they just gave me 2 points on it. So I know that what I'm increasing by is by 4 each time, and I'm starting at 3, so that has to be this sequence. And the other thing that's nice to do is just go ahead and plug in the values you have. So for example, if I look at 4 as the input, 4 times 4 is 16. 16 plus 3, 17, 18, 19 is indeed 19. So it produced the correct output there. And if I was to do 4 times 2, right, I'm just 4 times 2 and then plus 3. 4 plus 2 is 8, or 4 times 2 is 8, 8, 9, 10, 11. It produces 11, which is correct. So it's definitely C. And while we're here, let's go ahead and do the same thing for question 5. It says, which of the following sequence represents the sequence 5, 10? Well, okay, for that sequence, I know that I am multiplying by 2 each time, right? My generator is times 2. So I know it's a geometric sequence. So because of that, I can immediately eliminate these two because those would both be arithmetic sequences. But an explicit equation for a geometric sequence would have this exponent thing happening here. So I'm multiplying by 2. And the 0th term, if I was to go back, instead of multiplying by 2, I'd divide by 2. So this would become 5 halves. Well, 5 halves is the same thing as 2.5. So this is exactly what happens with A. With A, you're starting with the number 5 halves, or 2.5, and you're multiplying by 2. And the number of times you multiply by 2 depends on which term number you want in the sequence. So if you want the first term, it's just a single 2, 2 to the first power. If you want the second term, it's 2 times 2, which is 4. So this is it. T of n equals 2.5 times 2 to the nth power. By the way, if you plug in, the number 1, it would give you 5, 2 gives you 10, 3 gives you 30, and the number 4 would give you 40. So nice to check some of those out and make sure that they're behaving as they're supposed to.